All right, in this video, we are going to work the following inequality. We have 15 is less than or equal to 7 minus 2/5 x, which is less than or equal to 21. So this is a compound inequality that has a fraction in it. So, all right, so here's our inequality, and just like with any linear equation that has a fraction in it, one of the things that we can do is to multiply through both sides, or in this case all three sides, by the LCD to get rid of the fractions. So in this case we really only have one fraction, right? So its denominator is going to be the LCD. All right, and so what we're going to do is to multiply the left side by 5. We're going to multiply the middle side by 5, since we have a compound inequality, right? Kind of think of this as having three sides, left, right, and the middle. And then we're going to multiply the right side by the LCD as well. Okay. All right. And so if we do this correct, right, it should cancel out all of the fractions. All right. So next up, then we will simplify each side as much as possible. Over on the left side, all we need to do is to multiply 50 times 15, so that is going to be 50 plus 25, which is 75. All right. In the middle, since we have two terms, right, that's why I put that expression in parentheses, so I would not forget to take that 5 and multiply it times each of those two terms. So 5 times 7 is going to be 35, and then I'll have 5 times 2/5 x, and then 5 times 21 is 105. Okay. All right. So now then just keep simplifying each side. 75, that is as simple as it will get. And then in the middle, I have these two fractions, 5/1 and 2/5. They have a common factor of 5 between the numerator and denominator. So 5 goes into itself once, it goes into 5 one time again. So on top, I'll have 1 times 2, which is a 2. On the bottom, I have 1 times 1, which is 1, and 2 divided by 1 is just 2. All right, and then over on the, oops, I forgot to, something weird happened there. I forgot to tag down that 35. So it's 35 minus 2x. Maybe I just forgot to write it in there. Okay, so that looks good. 35 minus 2x. All right, so now each side is as simple as we can get it. The left side is as simple as we can get it. The middle is as simple as we can get it. And the right is as simple as we can get it. Okay, so the next thing is to use the addition principle with the goal, right? The goal is to get all the terms with an x in the middle, and then everything without an x over on the left or right hand side. And so the simplest way to do that is to subtract 35 from each side. All right, so over on the left side, I have 75 minus 35. That's going to be 40. In the middle, 35 minus 35 is 0, and then I still have minus 2x. And then 105 minus 35 is going to be 70. All right, so now I have every term with an x in the middle, and then no terms with an x on the left and the right. And that's exactly what I want, because remember, the ultimate goal here is to get the x in the middle by itself. And so I can now do that using the multiplication principle. I can divide all three sides by -2. And now whenever you do that with an inequality, right, you always have to be careful to make sure if you multiply or divide all of the sides by a negative number, then the inequality signs have to flip. That's very important. So over here on the left side, I have 40 divided by -2. That's going to be -20. Then the inequality sign is going to reverse itself. Okay. And then -2 divided by -2 is a +1. So I have +1x, which I just write as x. Again, this inequality sign has to flip as well. So 70 divided by -2 is -35. Okay. All right, so we have solved the inequality. The next step then would be to write this or graph this out. Okay. So I would sketch a number line. And then on the number line, I would put these two numbers, -35 and -20. When you do that, though, make sure that you respect the order, the natural order, right, of the number line, which is smaller things on the left, bigger things on the right. So the -35 is going to be on the left of -20 on the number line, because technically, right, -35 is smaller than -20. Okay. So again, you've got to be careful about that part here. It is confusing sometimes when the inequality signs are written the other way, but on this one, all you really have to do is to make sure that you respect the natural order. If you go on, start at 0 and keep going to the left, right, -35 is going to be past -20 on the number line. Okay. The next step is to decide whether the -35 and the -20 will get an open dot or a filled dot on the number line, right? And they will both get filled dots, right? The reason being is that they both have this or equal to. It's one way to look at it, but really, right, -35 and -20 are both solutions of this inequality. If I plug either of them into this, like say, for instance, if I plug the -20 into this inequality for x, I'm going to get -20 is greater than or equal to -20, which is true, and -20 is greater than or equal to -35, which is also true. Okay. So, and same thing for the -35. Okay. So that's what that looks like. And so then is we need to shade in the solutions, and the solutions here are trapped in between -20 and -35. So it's going to be this piece right here that you shade in. Okay, so that's what the graph looks like. And then once you have the graph down, then the interval notation is really pretty straightforward. It kind of looks like the graph, right? Here, -35 has a filled dot, and so the filled dot is going to correspond to a bracket, and the -20 also will get a bracket, right? It has a filled dot that looks like that, and the solutions are right in the middle here. Okay, and so that is it on this example.